continuity. So if a graph has no discontinuities, so no vertical asymptotes, no point discontinuities, no gaps in the domain or range, we say the graph is continuous. Okay? So some examples of discontinuous graphs. The classic ones are hyperbola. Okay, we've got gaps both horizontally and vertically with that one. A more unusual one, but technically x over x, rather than drawing the line y equals 1, you still get the same line, but because it's written as x over x, can't have 0 on the bottom of the fraction, so you can't substitute 0 into that, you get 0 on 0. So we get a point discontinuity. So that's discontinuous. You might get one of these step functions, split functions, sometimes they're called as well, where they're defined one way for certain values of x and another way for another. And we can see a jump there, there's a gap. So that's discontinuous. Now what's important about that is differentiability. In order for something to be differentiable, it has to be continuous. Not only continuous, but smooth continuous. Right? So something like our absolute value graph there, it is continuous, but it's not smooth continuous. Because at that point there, we get that sharp point. So what do we mean by smooth continuous? It means if I was to draw a tangent, I could draw one definite tangent. But look at that point x equals 1. Where would I draw the tangent? Because it's sharp, it's too hard to draw one. So that particular curve is not differentiable at x equals 1. A parabola on its side. The other thing you'll notice that I said there, not only does it have to be smooth continuous, but the tangent can't be vertical at that point. And so that particular curve is not differentiable at x equals 0, because I would get a vertical tangent there. This is what we call a cusp. But again, we have a sharp point. So it's not smooth continuous. It is continuous, but not smooth continuous. So that one's not differentiable at x equals 2. All right.